All right, apparently nothing can stop this talk, at least we hope so. Good morning, everybody, and thanks for the introduction, Sabine. I'm going to talk about understandable microservices. I believe that in the future, programming microservices is going to be the norm. Maybe I should avoid the word micro. I think the programming services is going to be the norm. So it's important to get to tools that make it easier, okay? Now, before I start talking about services, I would like us to agree on a very simple definition. If we can't agree on this definition, then giving my talk is going to be very hard. But I try to make it as agreeable as possible. So for me, as microservices in this talk are just autonomous services that run independently and communicate by message passing. So already from this simple definition, we can extrapolate a few interesting things. Microservices are components, unsurprisingly, right? So we are interested in having building blocks and to compose them. They have independent life cycles. So this means that you can start and stop microservices independently. Here I should start seeing some eyebrows raising, but we'll see about that later. And they operate concurrently. Okay. Now during this talk, I will ask you some yes/no questions sometimes, just to see whether you're still keeping attention or you understood what I'm saying, right? But you are a lot of people, so I will adopt the humming system. Are you familiar with the humming system? So when you want to say yes, you hum, in approval, okay? And if you don't want to say yes, then you just keep silent, also known as no. All right? Did you get that? Fantastic. All right. Why do people want to use microservices? Well, one reason is that you can replicate them, right? Here, Netflix is the king of replication in the cloud thanks to microservices, right? Well, I mean, you can replicate them if you get it right. Not all services are easy to replicate. And should it be a requirement that all microservices can be replicated? What do you think? No. Exactly. So for me, replication is a nice feature if you want it, and sometimes, but I mean, it takes time, and sometimes it's not worth it. It depends on your use case, right? As we've seen yesterday, I kept hearing this mantra, it depends on your user case, it depends on your use case, and so on and so forth. So replication, well, if you need it. Then why do people use microservices? Let's see another reason. Well, they have independent life cycles. This is important. It makes updates easier. Emphasis on easier, not easy. Okay? It doesn't make updating services easy. And why? Well, as we saw yesterday, as soon as you have any interesting and non-trivial system, you have dependencies, right? You have a service calling another service, it means you have dependency. So if you shut down a service that other services depend on, then you have to start thinking about dependencies and maybe even blue-green deployment, all that sort of stuff. So it's a bit easier, but not easy. Let's see another reason. Microservices are technology agnostic. And I think this is one of the most interesting aspects. Now, what does it mean? It means that you can take your favorite language or technology or framework. For example, you can make one service, if you like, using Python for some scientific computing, for instance, or maybe in another service, it is damn important that you care about memory management. Maybe you want to use C or C++. You asked me to make a microservice and I did it in Jolie, of course, or you might have some service in Java. Now, first of all, I would like to make the observation that this existed in service-oriented architecture already. This is not new, okay? I get a bit conflicted inside when I hear people that microservices are now technology agnostic. We have always been technology agnostic in service-oriented architecture. The novelty, though, which again people started realizing in 2008 already in service-oriented architecture, or maybe even sooner, is that we gave up with making a golden standard for integration of these services, okay? So it's a bit more bottom-up. Instead of having vendors pushing, this we discussed also with Olaf yesterday, instead of having vendors pushing down on us standards and say, you have to adopt these standards, now we have the community saying, hey, we want to do integration as we see fit. It depends on the use case, okay? This is good and bad. Good because it comes from the community, bottom-up. Bad because, well, now we need to deal with integration. Okay, we don't have a very strong guidelines there. And integration is complicated. I hope I don't have to explain why. I think we all agree that integration is the most complicated part of software, right? Yeah, good. Now, integration adds complexity, and this is one of the main reasons for which I think people started appreciating the famous Fowler's microservices premium graph, which says that you should adopt microservices only if your complexity is this big. Okay? So the idea is that the more complicated the system is, the better microservices scale with complexity. Well, this started a sort of trend. People started saying, if that's the case, you should think about adopting microservices only if you really need to scale. I started hearing phrases like that. Or you should adopt microservices only if you have really complicated software, which led to conclusions like use microservices only for big businesses and for big projects, big stuff. Okay, you can find a lot of statements like that in blogs, the web, all sorts of things. I disagree. Okay? I think this is the state of the art. This is what we should aim for. I think we should think about when to use microservices without having this sort of pre-made rules, only if you really need to scale or really have complicated software, because I believe the complicated software is everywhere. Okay? I'm not saying you should use microservices for everything. I think you should consider microservices seriously for every project, if you think it makes sense. Why do I think it is going to become so relevant? I think it's relevant already, but it's going to become more and more evident, because if you look at how software is made today, most of our complexity of current software lies in integration. Okay? Today, we spend more time integrating stuff than making the components that we integrate. This is a state of the art. Integration is not a hassle. It's where we get a lot of business value. So the idea is that complexity is widespread because integration is everywhere, so we should try to get good at it. And I think the microservices is the paradigm where people are trying this. They are trying to get good at integration because it's inherent to the paradigm. Just to give you an example about how important integration is, in Denmark, this is the region, the main region of Denmark, the Copenhagen, where we have the capital, Copenhagen. They wanted to integrate, to get a beautiful integrated system for healthcare IT systems, and they initially estimated 150 million euros to achieve that. In 2016, then after a while, they realized that the system they got was total chaos, and they said, we have some few technical problems which are related to integration. And people ask them, well, how big are these problems? Well, we need to pump up the budget from 150 million euros to 375. Okay? Now, this is a typical example of people underestimating integration, and also a typical example of the fact that most of the money that we spend in IT system goes in integration, not in the components we're making, right? If you look at this ratio. So this is the key idea behind the development of Jolie, if you like. Jolie is a language designed to get good at composing services together. This is the basic principle of Jolie. Now, some people may ask, why the heck did you make a language and not a framework? And the main reason, I mean, there are many answers. One reason is technical. If you make a framework for a language like Java, then developers can still get away from the framework and cheat using the basic primitives of the host language like Java and violate the principles of the framework. Okay? But another reason is far more important. It's a sort of design reason. Languages influence how we think. Languages give us discipline in how we structure software. Okay? So the interesting question here was, if we made a language oriented to microservices, we don't have objects usually, we don't have functions, we have only services. Then how would software shape up to be? So I like Jolie, mainly because it has a nice logo, I like looking at it. But I should say that it's the result of a collaboration between industry and academia, just like this conference. So we had a bunch of universities and industry develop Jolie over the years. It's open source, so you can go and download it. And I'm showing this picture here just to show that although we still have some major releases now and then, the project is very much alive. The code base is relatively stable. We never had breaking changes in the syntax of production code. I'm going to talk about the innovative part. At least I hope we will agree it's a bit innovative. Now, what are the targets, the target users of Jolie? Integration ninjas, because it's tuned to be a language for drawing integrations quickly, for example. And why the software designers? Well, that's because if you want to try out an architecture, you have a software architecture in your mind based on services, and you want to quickly prototype it and try it out, then Jolie makes it very easy for you to do that and then change things. I think it's also, and most especially, the right tool for unwise software designers, because as we will see, Jolie will force us to think about the data models that you have for each pair of services that need to interact with each other. So what do we need when we design a language for integrating components or services? We need to think about a few things. First, it needs to be good at dealing with communications. Okay? Microservices are based on message passing. Second, it needs to make it easy to deal with the heterogeneous and different data formats. JSON, XML, whatever it is. It needs to have some facility for defining APIs easily. It needs to provide us with some features to integrate for the integration of different behaviors. You have services with different behaviors and you want to integrate them. And that's like the ABC of difficult integration. And it needs to have access points as a primitive. Yesterday, lots of people were talking about endpoints or access endpoints. This is what I mean here by access points. All right. Why are access points so important? Well, it's because when you compose services in a network, you cannot, there's no concept such as accessing the service. You can only access the endpoints that the service is making available to you on the network. Okay, so that's what you should be using for composition. So if you think about this huge island of complexity where you have different kind of data formats and different ways of communicating and so on and so forth, the purpose of Jolie is to build a huge Pac-Man that's going to eat it up for you, right? So enough with that. Let's code. Well, before I code, let me show you how to do Hello World in Jolie. All right? The structure of a Jolie program is very simple. Every Jolie program is a service. We don't have functions, we don't have procedures, we don't have anything but services. All right? So when you define a service, you have a main entry point. This is a block of code that defines the behavior of your service. You can include libraries and you can invoke services. Okay? So the way you read this program is include console from the standard library. Then we have the program entry point that defines the behavior of our service. And here the code is invoking operation print line at service console. Okay, so this is an external service. We are passing a message containing the string hello world. So now I'm going to try and make this work. We had a few technical problems, so just allow me to open a few terminals. Let's see, so I want to print something on screen. Atom is the new Eclipse. It takes a while to power up. All right. So if I go here and I create a file, so I include the console. And now I print something on screen. Now, when you send a message in Jolie, okay, can you see that? Is it readable? Yep. Good. When you print something, you care about knowing when the thing you wanted to print has actually been printed. Okay? This makes it a synchronous operation. In services, you deal all the time. You have to make choices all the time. Is it a synchronous or an asynchronous operation, right? If you write it like that in Jolie, it's an asynchronous operation. Done. If you want to receive an acknowledgement, you add a couple of parentheses, and now it's a synchronous operation. All right? Well, notice that why did we choose the syntax? It's because maybe the reply contains some data, and then you can receive it in a variable like this. In this case, when we print on a console, we don't receive any data, just an acknowledgement. So we just eat up the message and not store it anywhere. Now, hopefully, if I run this, it actually prints hello world on screen. Yes. Which is not the most amazing achievement in computer science in 2019, I would say. So let's go and see something more interesting. But what I wanted to highlight here is that we're invoking a service. Okay, so now this is my own console running in my local computer. If you moved this console service to another computer, you wouldn't change this code. This is very important. Okay. So the idea here is that all components in Jolie are services. The basic unit of a reusable component is a service. So let's try to see how we can use this idea in order to make systems. Now I'm going to make a slightly less trivial system where we have a client and a service. I'm going to make a calculator service which exposes an API containing an operation sum. Now why am I separating this? What is the rectangle here? Can you guess? Yeah. It's the access point of the calculator. Do you think we will be able to have multiple access points? Yeah, why not? A language for services should allow for you to define multiple access points. If you use some Java frameworks, you might now think for a minute about how you can do that in Java, and in some frameworks it's a problem. I think it should be a feature present in all frameworks and languages for services. All right, so let's build a calculator. Now, first thing you have to do in Jolie, which I think is just best practice, but the language will actually force you to do it, very important, is you need to think about the data model between the client and the calculator. Okay? We saw talks yesterday about you should think about it. In Jolie, you must think about it. As simple as that. So first, you define the data type that you're going to send from the client to the calculator. We are going to call it a sum request. It's a tree. In Jolie, everything is a tree, a bit like in JSON. All data is a tree. It has two subfields, one called x, which is an integer. Oops. And another called y, which is also an integer. So this is now a service that we're going to build for summing up two numbers. Nothing groundbreaking, but it suffices to show the key features of the language. Now, we make the interface that is going to define the API that the calculator service exposes to the client. I'm going to call it calculator interface. What does it expose? We said, well, it should be a sum operation. Is it synchronous or asynchronous? Synchronous, right? It should return something. Some people, now asynchronous is a very overloaded term. Some people use it for referring to reactor implementations, for example, and things like that. What I mean by asynchronous or synchronous here is the API. So for me, synchronous is something that returns something to you that you have to wait for. And asynchronous, I see Olaf nodding, very good. Kind of got scared there. And asynchronous simply means that you send a message and you don't care when it will be processed. All right? So we want to get a result, so it's synchronous. Synchronous in Jolie is request response. We got this nomenclature from service-oriented architecture. Still works. We have a sum operation that takes as input a message of type sum request and returns an integer. As simple as that. Okay? So we have now defined the API and the data model for our service. You can imagine more complicated data models will have more types, more complicated types, so on and so forth, but the discipline is this. It's always the same. Okay, now let's define the client. Yesterday we talked a lot about you should think about the end user and whatever, so now I'm starting from the client today. So, what should the client do? Well, first of all, we should import the data model for interacting with the calculator and this API. Right? Done. Second, we should define how we are going to access the calculator service. This requires a bit more information. So we have two sides to an access point, An output port defines how clients are going to refer to the service, how they're going to contact it. So now I define an output port to the calculator. What do I need to define? Well, first of all, I need to define the API that I expect the service to have. Then I need to write where I expect the service to be deployed. Here I'm using a TCP IP socket at TCP port 8000. Here you might use a service registry or whatever you liked, right? This is just a simple example for now. And then I need to define the transport protocol that the service is using. Here I'm going to use a binary protocol. I like efficiency, called SODEP. What do we use the calculator service for? Where we invoke it on operation sum. We pass our two numbers, like, I don't know, 3 and 6. We get a result, and then I could print it on screen. Mind-boggling. Printing on screen, so I need my console. All right. Now, if I try to start the client, of course, it will get very angry, because there is no service out there. Okay, so let's define a service. So the calculator, what do I need? What do I need to import first? Interface, yes, the data model. Very good. Do you develop Jolie code, Balint? All right, then I need to define the access point. Before we had an output port for the clients. For the service, we have an input port. Very simple, because we receive input messages. Now, the input port, we are going to deploy it at the location expected by the client, with the transport protocol expected by the client, and the API expected by the client, which I hope is not a surprise. What's the behavior of the calculator? We receive a message for operation sum. That's it. This is the syntax for we receive a message for operation sum. We don't have sockets. We don't have anything like that. In Jolie, communication is a primitive. So this is an input. We receive the request, and then we are going to send back a response. And now you have to write how you compute the response given the request. And the response is just summing up the two numbers. Okay? Do you get this code? Very good. So now hopefully if I start the calculator up and I start my client, I see a 9 on screen, right? Where is the 9? Ooh, let me move this a tiny little bit. Is it fine now? Very good. Let's fit. All right, so now I have a 9. But the calculator died because the calculator is a service that I defined to be operational for just one invocation. That's what I wrote in my code. So if I run the client again, it will get angry because the calculator died. This is not what you would like to have on the internet, right? What you want on the internet sometimes is an always available service that can deal with many clients. So the way you do that in Jolie is by saying, I want you to be able to handle many clients, and you will handle them concurrently. It means all clients, whenever you receive a request for some now, we will spawn a copy of the service, well, of the behavior of the service, serve the client, and we will remain available for other clients, and they're all treated concurrently. If you're dealing with a serial resource, like some hardware, maybe a serial port, and your service is guarding that, you don't want that. You want to treat all clients sequentially. You just write that, but you never change the behavior of your service. Now here I like concurrent. So I run the calculator now, and then I run my client, and I get a 9, and I get another 9, and I get another 9. So here are all my 9s, so it works. The client is a bit boring though. Maybe you won't believe that I'm actually summing up numbers and I'm just returning 9. So I'm just going to put the command line arguments here. All right. Jolie is not JavaScript. I mean, if you're sending a string, let's try it out. if you're sending a string, then you get a mistake, you get an error from Jolie saying that, hey, you tried to contact the service that was expecting an integer, but you sent a string, right? So it checks at runtime at least that you're respecting all the APIs that you defined, both on the client side and on the server side. You might ask, why do you check it on both sides? Well, on the client side, it's earlier, so it's better. The message never bothers the service. And we check it also on the server side because maybe the client is malicious and it's trying to trick you, right? Okay, so now we have a client that works with any sorts of numbers. 3 plus 6 equals 9. 3 plus 62 equals 65. All right. Now, what did we learn? We learned that APIs are defined as interfaces in Jolie, and that the interfaces are exposed on ports, like input ports, and these are our access points from a linguistic perspective. Now let me show you something else. Suppose that you got tired of using a binary protocol and your boss is saying, well, it's nice that now you played with your prototype architecture, but now we need to go in production on using HTTP. Okay, so how can you use HTTP? Well, you just go and change the protocol to HTTP. So now you restart the calculator, and hopefully, I say hopefully because I'm running the Git version of Jolie, I access localhost at the right port with 3 and 9, and I do get a response in XML. Okay, so now I have an HTTP service by changing one line of code. I didn't change the behavior of the service because the behavior is the same, right? So this is a sort of contract that Jolie makes with developers. Behavior is independent from the deployment details. You could use JSON here too, or whatever is suitable for your architecture. But now the client that you originally wrote is very unhappy. If you try to use it, it will detect, hey, what the heck? What protocol are you using? I wanted a binary protocol, and now you're using HTTP. Okay? When you are in situations like that, you just make 2 access points. Right? So I'm going to move HTTP to port 8001, and I'm going to use the binary protocol on port 8000. And now the 2 ports are for the same service. So you have 2 access points that use different protocols to the same service. So now if I restart the calculator, made a mistake. Calculator 2. You need to give different names to input ports. All right, now it works. So now my client works. And of course, I put the wrong TCP/IP port here, and the web browser works too. Okay, so we have multiple access points. Now the deal is that you can actually use way more. You can combine different communication media. For example, here I use TCP/IP, but you could also use Unisockets or Bluetooth. And you can use binary protocols, SOAP, HTTP using JSON, XML, or whatever you like. I don't care, right? I mean, this is a language for microservices. We are supposed to be technology agnostic. And we have that too, actually. It's not, we have an experimental plugin for the language itself, but I think that Claudio and Bali maybe also, you did some experimentation with offering AMQP as a service that Jolie can invoke. We also had dbus at some point for orchestrating Linux applications. And the way it works is the way you expect. We have some data in Jolie. It can get, we have bidirectional transformations with all of our transport formats, the data formats. For example, the binary format used in SODEP or XML for SOAP and stuff like that. Something a bit more surprising is that if you write, for example, an HTML form and you send it over to Jolie, Jolie will be able to convert it. Okay? We actually use Jolie as a web server too. So if you have an HTML form where you have 2 fields, name and surname, and you send it, then Jolie will see it just as a normal message as anything else. All right. Now I cannot give you a full walkthrough of Jolie in a keynote, but I can show you some cool features. Something that happens a lot when you make a microservice architecture is that you connect them, and the most important pattern, I would argue, is the proxy. Okay, we make a lot of proxies. An instantiation of the proxy, a specialization of a proxy, is an API gateway. It's a smart proxy, as I call it. Now, what does it do? Suppose we want to, suppose you have a calculator and you want to make an API gateway that gives access to the calculator, maybe because the calculator is in your intranet and now you need to expose it to the internet, very simply put. Well, what you can do is you create a gateway usually. Now, I need to include, of course, the calculator. I need to define an output port to reach it. And I'm going to choose the binary protocol here. And then I need to define an input port for the gateway, right? A gateway is just a service, usually. And it should also be in your architectures, I think, that has an access point. So let's define the gateway. I'm going to publish it at port 8002 with HTTP. Well, now I could write some code here that manually takes the message from the client and sends it over to the calculator. But I won't do that. Instead, I will just say, wait until we are shut down and use a native primitive that Jolie has for building proxies. It happens so often that we made it native. So the aggregates primitive, forgive us for the keyword, it means nothing like the aggregation framework in MongoDB. It means take a service, like calculator, and expose it on this input port. So now we have created a proxy on this access point for the calculator. Notice that the gateway uses HTTP and the calculator is using the binary protocol. Okay? So I'm just going to hope that this works out. So I'm going to, without restarting the calculator, because this is supposed to be non-intrusive, as we saw yesterday, I'm going to start the gateway. Wrong directory. And voila. And now if I access this on port 8002, I get the right reply. Okay? So Jolie here is taking care of a lot of stuff. It's taking care of receiving an HTTP message from the client in HTTP, convert it to the binary protocol, contact the calculator, get a binary reply back, convert it to an HTTP message for the web browser. All right? We didn't have to write any boilerplate code for that. And that's right, because it should come naturally out of the definitions of our access points. The access points tell Jolie which data format should be used for everything. Spoiler alert, we got this in SOA already. We got a lot of inspiration from WSBPL and WSDL, right? We had endpoints there, we had protocols in there. This is just a way of exploiting the concept even further. All right, I have something I don't really like in this architecture, which is that I need to start the calculator and the gateway separately. This is perfectly fine if the two services are managed by different companies or businesses, right? So that's what we wanted to do. But suppose they're handled by the same business, okay? What would you want to do? Well, I would like to be able to start a single, the whole system with just a button, right? And normally you would use orchestration for that. In Jolie, we have primitives for orchestration too. By the way, this is not orchestration as in service-oriented architecture. This is orchestration as in containers. So you just embed. That's the keyword for when you get started, please start also this Jolie service. I won't have the time to show you the details, but you can also start Java services or even JavaScript services and everything works automatically. But today I'm going to stick to Jolie. So this means that when we start up the gateway, the calculator also starts. So now if I just start the gateway without starting the calculator, I can use the gateway, right? Because the gateway took care of orchestrating the startup of the calculator too. If you stop the gateway, it takes care of shutting down gracefully also the calculator for you. Okay. Now this embedding or orchestration, if you like, opens the gate, gate for gateway, I never realized that, to handling heterogeneous systems. Now suppose that I want my gateway now to give access to 2 separate services, okay, one for time and our calculator. And the specification says you have to offer both services at the same access point of the gateway. I could have 2 separate access points, no problem. But it becomes non-trivial when you want a single access point for both services to the internet. And the way you do that, I'm going to be lazy now because we're running a bit late. I'm just going to include the time service and aggregate it at the gateway, okay? You might ask, what the heck did you just include? And hopefully I can find out. So that's the Jolie standard library. You find the time service. Why is it asking for my password? God knows. So the time service is implemented in Java, all right? And there's an embedding that orchestrates the startup of this Java service. And what will happen, this is basically an object, well, it's a class with a method for each one of the operations that the service implements. We can see the data model and the API here. For example, I can see that there's a method called getCurrentDateValues. So that should mean that if I start the gateway now and I try to access this, I access the time service. So now Jolie has translated the HTTP message to a Java object, a POJO, gave it to the Java service, got the reply, translated it to HTTP again. So we have this kind of hybrid architecture so very easily. Okay, that's about the basics of Jolie. Any questions about the basics? Yes? Yes, currently not with the embedded native keyword. But the embedded keyword supports a plugin architecture. You just put a jar inside of the installation directory of Jolie, and you can define new ways of deploying things. We are working on integration with Docker. We already have Docker as a Jolie service app, so that should be fairly easy. So we are working on that. Other question? Yep. Well, concepts, I'm not sure. I think we support already existing concepts better, because the idea is that since you have this definition, which is machine checkable of a Jolie interface, right? We use that in tools that generate test skeletons for you, so that you can. It helps you in ensuring test coverage. Testing is something from a theoretical perspective that we can never automate, right? So at least the generation of tests that cover the use case, because it depends on your intuition of the use case. So that's something that we're trying to help with. All right. Now, for a more concrete example, suppose that you want to make money using Jolie, and you have a beer with a friend in Dortmund, and your friend says, well, Fabrizio, I think a good business case would be to commodify Chuck Norris jokes. It's hard to share Chuck Norris jokes on the internet. It's hard to find them. I have to Google them. There's no web service to find them and then share them, right? So this is the business case. You want to build a platform for sharing Chuck Norris jokes. Now, of course, your friend is full of ideas, but he's broke. And he tells you, well, but I mean, how hard can it be? I mean, there's a couple of services you have available. Can't you just code something that integrates them? I mean, he found that chucknorris.io is a web service that allows you to search Chuck Norris jokes. And he also found out that the Telegram creators made a website called Telegraph, where you can just make blog posts without, I mean, in a programmable way. So can't you just integrate these two and make a platform for sharing Chuck Norris jokes? Of course. So since we ran a bit late, I will spare you the live coding. But the idea is as follows. And now hopefully you have enough concepts to understand how this works. I'm embedding a web server, okay? I want to make a web application, so I need a web server. Of course, we have a web server written in pure Jolie called Leonardo. It looks like this. It's a rich 253 lines of code for our full web server. And the way this web server works, well, it's so complicated because it's got some templating in, but essentially the core of the web server, what is a web server? Can somebody tell me what a web server does for serving HTML pages? Yes. What does it do? And where is the HTML stored? In a file. Yes. So the essence of a web server is something that receives an input, and we can write that in Jolie very easily. Perform some sanity checks such that you're not trying to access directories you don't have access to. But ultimately, it's very simple. It will read the file that the client asked for and return it. Done. That's a web server. All right. So we have a web server. Of course, it's a service. Very important. You don't need to know exactly how the web server works or how you need to deploy it or read its documentation too much, because in Jolie everything is a service. So you just embed the web server. You orchestrate that. When we start our web application, we start also the web server. Okay? The web server gives you an API. Voila. It's an operation called config for configuration. What are you configuring the web server for? Where you are telling the web server which services should be accessible through the web server. Okay? You can have static HTML content, or you can also use the web server as an API gateway, using the primitives that we have already seen, so nothing new here. And here we're telling the web server, look, I'm going to expose two services. One is going to be called Chuck Norris. It's the service for accessing and searching for the jokes. And the second is a service for posting stuff on Telegraph permanently. Okay? We are going to use that to share our Chuck Norris jokes with our friends. Now, Telegraph is trivial to access in Jolie, because the only thing we need to provide the web server with... Oh, sorry, I meant Chuck Norris. The Chuck Norris service is trivial to access because we just need to provide an output port, okay? That's already a web service that does what we want. It exposes a search operation at api.chucknorris.io, so we just need to offer it through our API gateway, and our job is done for searching for jokes. Okay, then the second thing we want to do is to expose a service called Telegraph Poster for posting permanent stuff on Telegraph. Now that's a bit more involved. We need to define an auxiliary service, and surprise, surprise, the keyword to do that is service. Now what does Telegraph Poster do? It accesses Telegraph, so we have an output port for Telegraph. And Telegraph, unfortunately, does not allow you to programmatically call its API and post a blog page unless you have an account. Right? So the idea here is, well, let's make an auxiliary service that we expose that offers one operation called create page, and it has a workflow inside. First, it creates an account for us, an anonymous account, because we are lazy. And then it gets an API key, an access token, and then it creates the page with our Chuck Norris joke with this new access token that we got. All right? So it's a workflow. We want to hide all this complexity from the user. The user should just be able to click a button and publish on Telegraph. Okay, now how hard can it be to start up all this stuff? Well, you just Jolie it, and since we used embedding, it just starts everything up, the entire architecture. You can Dockerize it. This is actually Dockerized. You can access it at the end of the talk. And it says, hey, I published something at port 8080. So let's see what we have there. All right, so we have this beautiful web interface. And I'm searching a joke that contains the word computer. Now I click this button. What this button does is very interesting. Now, of course, we expose our APIs using REST. But what kind of code do you want to write in your client, in your web code? Well, you want to use REST, but REST doesn't exactly give you clean code if you use it directly in your HTML or JavaScript. So we provide you with a library called Yo for Jolie, which says, hey, give me the Chuck Norris service exposed by the API gateway. Okay, this is the web server we're connected to. What the library will give you is a JavaScript object that exposes every operation in the API as a native method. So we can actually call .search, pass some input, and then we have an asynchronous API that uses promises that allows you to consume the result. All right? So we're really calling Chuck Norris.search here. We see the service natively, essentially. All right, so if I click this, what happens is that we got a Chuck Norris joke from the Chuck Norris API website. Now when I click share this wisdom, we are accessing Telegraph Poster instead, our other service, and we are calling the create page operation. So as you can see, you get very clean code because it's aligned between the client and what you wrote in the Jolie services. All right. So if I share this wisdom, an account got created at Telegraph, and we use this new account, we got an access key, and we used it to create a blog post. So if I click here, you can send this link to your friends, and you created your Chuck Norris wisdom on Telegraph. Okay? So we implemented our business case in a few minutes, but I used some previous code. I think it took me about 20 minutes to write all this stuff up. All right, you can try the demo line. I wrote a tutorial about how I wrote it. You can find the source here. You can get it from Docker. You can pull it. You can run it. And you can start spamming Telegraph. I hope the Telegraph people are not listening or will never see this video, but maybe they will be glad that they've been used for a technical demonstration. And try it out. All right. Time is ticking, so there are other useful native features in Jolie that I won't be talking about today. Some are about service discovery. It's a primitive. If you want it, I don't think that service discovery is necessary in all architectures. There are primitives for sessions. If you want, for example, to keep track of some state and, like, I don't know, to implement an authentication protocol, a third-party authentication protocol like OAuth. There's distributed fault and compensation handling because microservices get into faults all the freaking time. We applied Jolie to a few things. We think it's very useful for digitalization. So we use Jolie to wrap some existing software and offer an API. Integrate business processes, e-commerce, and lately we've been exploring the applications to the Internet of Things. The future, I think, is very interesting. I mean, what can we do further rather than just make it easy to write microservices if we have a language for microservices, right? And the key here is that, you know, a bit like in refactoring, you have some languages that allow you to do some automated refactoring thanks to types, like in Java, right? You extract a constant, for example, and things like that. We could do similar things for services. For example, can we define some automatic strategies in Jolie to help you in replicating your services and automatically verify your code to check that, yes, this is scalable. Give you hints about the scalability of your code automatically. Now, many services, if you want to get something done quickly, you write them stateful. It's convenient because writing stateless services in complicated scenarios can take you a very long time. But the patterns that we follow when we want to transform a stateful service in a stateless service are always very, very similar. So can we automate that? Can we automate the process of taking some stateful code and make it stateless, right? Of course, this would have some limits, but I think there are a lot of interesting applications where this thing would work. And then, of course, support for more protocols and communication technologies. Jolie is as useful as, insofar it can integrate with what you have, right? So we're always interested in extending its integration capabilities. And this ends my talk. Thank you very much for listening.
Thank you very much. Are there questions?
Thank you very much for the very inspiring talk, Fabrizio.
Thank
you. You seem to have most, if not all, of the technically challenging areas of service orientation covered in the language. So I can ask a hard one, a tough one. How do you deal with breaking changes in the service contracts?
Currently, we deal with them. So there are different things that you have to do to deal with breaking changes, right? First of all, you have to detect them. So Jolie helps in already at runtime. So for example, if there is a breaking change, then the client gets a notification from the server that is more informative than usual, I think, because Jolie uses the data model that you defined in order to give you more information about what got broken exactly. At Italiano Software, we are experimenting with making these checks static, because we deploy Jolie services in a framework called Jung. And this framework is a sort of like the control panel that we saw with Nginx yesterday, right? So it knows about all the contracts that you have in your system, and when you change one, it can statically check that the data models that you defined for the clients are still compatible with what you have at the server. So you can have some changes, but we can detect whether they're breaking, right? It is still a bit of a work in progress, but I think that defining the data models in the language is essential to achieve this. I think that what we can do is to automate the check of compatibility of the interfaces and the APIs. Then you should always ask yourself, is the behavior still compatible? And checking breaking changes of behavior is undecidable in general. We have a theoretical result that prevents us from doing it. And this is something you should do by integrating a testing architecture, I think, in the control plane.
Thank you. Another question?
Yeah, thank you for the talk. My question is there an explicit way to customize the API endpoints? So I'm thinking of a RESTful HTTP.
What do you mean by customize exactly?
So it's a real RESTful API.
So if you use HTTP in one of our ports, okay, then what you're going to get is something REST-ish, but not fully RESTful. If you want to achieve, so the reason for that is that in order to make a correct RESTful API, you need to know about the behavior of your service, and this is something we cannot automatically infer. So what you need to do is to go in the input port, for example, like, I don't know, where is the calculator again? Here it is. Now the key here is that this is information that has to do with the transport protocol being RESTful. So what you're going to do is saying, all right, my operation sum has this HTTP method, all right? And then you should you define whether it is get, post, or whatever you want. So it's information that we keep in the API, in a sense.
So thank you, that was very interesting.
Thanks.
One question, what does Jolie support for implementing a more complex business logic inside a microservice? So
Ooh.
do you support something like object orientation or other modern languages?
Right, we don't have objects. If we have I mean, you can define, for example, recursive procedures, if you like, which are not objects. If you need more complicated behavior, what you would do is typically to define a service. You give it a name, my auxiliary something, for example. All right. So now I'm talking about splitting the code, if that's what you meant. Then there is also another side I will talk about later. But here you would define, for example, your an operation, maybe it's a function, maybe it does something, and now you can call this inside of your code as if it were a service. And now you might ask, why don't you just define a function? And the reason is that if you define it as a service, you can always take this thing out, copy it into another file, and make it an external service, and you don't need to change your behavior here. Okay, so mobility for us is very important because this keeps the architecture flexible. You can decide later where you want to move stuff, right? So that's one answer. Then another answer is that business logic gets complicated because of the structure of your workflows, right? Maybe you have to call two things at the same time. That's one thing you might have to do. Usually you achieve that with the vertical bar. This means do these two things in parallel. Or maybe you need to, I don't know, first you need to log in, and then, semicolon, you can access the sum operation. So giving access control, for example, is something that is also native in the language, like that. And we have, for example, maybe you open the cart. So now you logged in, and you can add elements to the cart until you log out, the provide until primitive of Jolie, right? So we also have primitives for that. Yeah.
Then last question.
Yeah, thank you. Thank you for your talk. It's very interesting. And I just want to ask if it's, we want to embed more different kinds of third-party middleware or services. Do we have any support for that? I mean, how easy it could be?
Can you give me an example of something you would like to embed?
Like if you want to embed Ocelot, if it's like API gateway.
Yeah. So for me, Ocelot would be a service in all of this. So I would just take it up as a Docker container and interact with it through its access point. Okay. What we're interested in embedding more is different languages like Python or R, because we have a lot of people doing statistical stuff with this. I think there's a bright future in making embedding plugins that interact, like we said before, with Docker natively, such that if I got, for example, an Ocelot container, I would just start it up by saying Docker : my Ocelot container, and then I would get an access point to interact with that. That's something I think would be very interesting to do.
Okay, thank you.
Thank you. And let me ask one small question. I really like the idea of having a language supporting the way we think. But as I have seen, we have to specify or to define a lot of technical stuff in the code. So is there any way to separate it somehow?
What do you mean by the technical stuff? You mean the data model and the interfaces, I guess?
Yes, protocols and so on.
Right, so this is stuff you normally have to define anyway. If you have a Java framework, you have to write the stuff with a different syntax anyway. Yes, you can separate it. You just, you know, and we usually do actually, so very good question. So maybe you want all the deployment details in another file, right? And then you just put it there. That's one way of doing it. You can actually even, which is kind of crazy, you can put the deployment file as an HTTPS or an HTTP server. And this will actually work. Okay?
Sounds good. Thank you very much. And now we have a small present.
Thank you so much.
Interesting keynote. Thanks.
Thank you.
And now we have almost 20 minutes for the next coffee break, and then we are in time again if we meet at 10:30 in this room. So